Okay, so let's look to solve this last example for solving equations. So we have solved 2 sine x plus cosecant of x is equal to 3. So first we notice nothing is quadratic, so there's not any Pythagorean substitution that I can do. Right? And then I can look at this, I can say, but wait a second, cosecant can be written in terms of sine. So sometimes we write in terms of our sine and our cosine to help us out. So we can say 2 sine of x plus 1 over sine of x is equal to 3. Okay. Once again, if you don't like fractions, we can multiply through by the denominator. So that's going to give us 2 sine of x times sine of x plus 1 equals 3 sine of x. I just multiplied by the denominator, which would mean I have 2 sine of x squared plus 1 is equal to 3 sine of x. And once again, some people find it easier to look at it in this form. Other people find it easier to write and look at it in this form. They both represent the same, right? The quantity sine of x squared is the same as the sine squared of x. Okay. Moving things around, I've got 2 sine squared of x minus 3 sine of x plus 1 needs to be equal to 0. Let's make a u substitution. Let u equal the sine of x. So I have 2u squared minus 3u plus 1 equals 0. So that's going to be, if I factor, there should be a 2u minus 1 and a u minus 1 is going to be equal to 0, which means u is 1/2 or u is 1. But what was our substitution? So sine of x is equal to 1/2, or the sine of x is equal to 1. And with enough practice, we should be able to solve this and say, hey, I know that x is going to be in the first quadrant. Right? You can always draw it out, help yourself. X is going to be in the first quadrant, reference angle pi over 6. All right. X is going to be in the second quadrant, reference angle pi over 6, so that would give us 5 pi over 6. And then I have the sine of x is equal to 1, right? And I know that the sine of x is equal to 1 at pi over 2, so that would be x equals pi over 2. Okay. Now, all of these solutions are less than pi, so that meets the less than pi. Do I have any that are going to be negative? Well, let's see. If I go negative pi, nope, that's going to be too far, and that's going to be too far. And if I go negative on this one, that's negative 3 pi over 2. So the only solutions that I have on this particular interval are pi over 6, 5 pi over 6, right, and pi over 2. Okay. Could I look at it graphically to double check my work? Sure. Let's look at this graphically. All right, we turn it on. Go to y equals. Let's clear our graphs. And we can say, well, I've got 2, right, times the sine plus, now cosecant is the reciprocal of the sine, so I've got to make sure reciprocal of the sine. And I want to find out when does that equal 3. I want to make sure I'm in radian mode. And my window from negative pi to pi. All right, so I'll go ahead and graph. See what I can see. And so I can see that some of the work seems to be towards the bottom of my graph. Right? Some of the work seems to be towards the bottom of my graph, and I seem to have intersections up here. Right? And remember, what was that initial equation? Was equaling 3. So I'm going to go ahead and adjust my window where I can clearly see the intersections near the top. I'll go ahead and regraph. And so I've got this interesting graph. And I can see that there does seem to be 1, 2, and then 3 intersections, with one of the intersections being at pi over 2. Right. So I've got my intersections, and I could double check those values: pi over 6, 5 pi over 6, and pi over 2. Right. Second, calculate the intersection. Right. And I can arrow, make sure I get close to the point of intersection, enter once, enter twice, enter thrice, and it's telling me 0.523598. I'm not sure about that value. Pi over 6, 0.523598. Okay. Once again, you'll get better by practice and by asking questions. A lot of this analytic trigonometry, once you have your unit circle well memorized and you're comfortable with the algebraic manipulations, right, then you can be successful.